My name is Fumito Shikeno of Toko Electric Company. I would like to give a brief introduction of my company. Toko Electric was formed in 1928. Its origins were in the same company as Tokyo Electric, TEPCO, and the Tokyo Lighting Company Limited. Toko Electric has been involved for 82 years in sales, manufacturing, and development of electric distribution equipment for electric power industry. Personally, I've worked for over 20 years development automated grid control system. Today, I would like to introduce to you to the STiNC Smart Grid Controller. Toshiba Toko Metering System, TTMS, manufactures smart meter for TEPCO and was formed 2009 as a joint venture between Toko Electric and Toshiba, combining the electric meter business of both companies. TTMS manufactures and sells electric and gas and SCADA sensors to domestic electric utilities, other industries in Japan. Wireless Glue Network Inc. is our software partner in US and Japan. They have been working with us intensively since triple disaster in northern Japan last year. Toko Electric and Wireless Glue Network work together specifically to provide solutions to the needs of demand-side energy market. We have Wireless Glue CTO John Lin with us today to speak for us on our behalf about the Toko Solutions TTMS devices wireless glue software. Thank you, and over to you, John.
Okay, thank you very much. Before I get started, how many of you are related to the electric utilities industry or have any directly in the utilities or supplier to utilities? Supplier to, okay. Okay, yeah, so today, first of all, I'd really like to thank you, first of all, Toko Electric for this time to, for my opportunity to present for them here at Java 1. And I also like to thank Oracle for this opportunity too. Use of Java in embedded controllers is, I think, something quite new, especially when it is used with the Java Standard Edition, which is actually the topic here. And we have, Toko Electric has been pioneering the use of Java-based controllers in Japan. Now, the particular technology that we're talking about is demand-side management. That is quite new in Japan. It is still pretty new here in the United States and not so prevalent in, I think, Europe. Correct me if I'm wrong. And the demand-side management is a very interesting subject for utilities and electric utility industry because it requires a lot of data to be processed, data to be transported, data to be analyzed, and command and control to be implemented. So we have a partnership going on here, and that Mr. Kano had referred to, and this is a three-way partnership. First and foremost is Toko Electric, and as Mr. Kano had explained, Toko Electric is a direct subsidiary of TEPCO, which is Tokyo Electric company, and that is the main utility that serves about 30 million people in metropolitan Tokyo area, and has several very large nuclear power plants. Now, as you know, after the disaster last year, there's been a severe shortage of electric power, supply, baseline power, and so in Japan specifically, the market has actually evolved quite rapidly towards alleviate the supply or the needs of electric power, not through increasing baseline demand, but by demand management itself. Demand-side management itself. So Toko Electric, being a electric infrastructure provider, has really spearheaded a initiative to provide new infrastructure technologies for the demand side. And this is what it's all about. Now, Toshiba Toko Metering System is also a sister company of Toko Electric. And they are one of few companies in Japan that actually manufactures the smart meters themselves. Now, one of the key points in demand-side management is to be able to obtain accurate data of electric usage, because when you talk about demand-side management, you need to account for usage accurately. It's not sufficient to know electric usage to, let's say, 10% accuracy. No, that's not. That won't work, because this is all basically billable energy, and so it has to be accurate to the actual smart meter itself. And so the partnership that exists in this particular form enables Toko Electric to actually obtain the electric meter data through the meters that are deployed in the TEPCO area, and these meters are from Toshiba Toko Metering Systems. Also, Toshiba Toko Metering Systems provides commercial, industrial energy measurement equipment, which are basically data collectors that are installed in commercial settings like in factories. I'm from Wireless Glue Networks. I'm founder of Wireless Glue Networks, which is a small company, startup just across the bay in the East Bay. And we provide Java-based software that runs on the platform that Toko Electric provides. And we operate both in the US and Japan. So I'd like to first introduce the concept here of T-STEP, which is Toko Smart Energy Open Platform. You hear a lot about, in a sense, very peripheral electric service providers talking about the smart grid and the different services that they would like to provide. But in fact, what is very unique and the strength of Toko Electric is that it is part of the electric infrastructure. It does provide all the infrastructure within the Tokyo metropolitan area. And that infrastructure spans both the supply side all the way to the demand side and the distribution thereof of electricity. And it's also unique in the electric service provider space because it is purely an electric service provider, infrastructure provider, whereas other companies have a much larger, I guess, portfolio of services and products. Toko Electric's sole purpose is for delivering energy. Now, if you look at this, you'll see several components to this Toko Smart Energy Open Platform concept. There are smart campuses, which are basically type of community, smart towns that have different commercial and residential areas, shopping centers, another more of a tightly knit system type of setup for in terms of electricity. It's just a big building, and factories and buildings. Smart buildings are another different category or genre of demands. They usually have automated lighting controls, HVAC systems that are in one system, and they are served by devices that are called building energy management systems, which have echelon or backnet systems. Whereas if you go to factories, you have you have lawnworks, you have backnet, but you also have other types of command control systems in there. Campuses, it's similar to buildings, but also more smart buildings, but it's more widespread. Shopping centers, smart towns, they don't actually have standards quite yet, and in fact, the control of towns and shopping centers, or more of the towns and campuses side, are not direct, but they're more driven by, for example, real-time pricing or some kind of a incentive structure, and overlaid on top of this, you have, besides electric pricing to affect demand side usage, you also have direct demand response signaling or demand response based dispatch signals that come out from the supply side. So all this, Toko sees this can be provided with a common platform, a common architecture, a common computing platform, common communication platform, and that's the whole concept behind the T-step. What is that common platform that can be deployed in all these different use cases and scenarios? And that's what the talk is about. Here's just a kind of a smorgasbord of different types of products that Toko provides, and we actually have a little bit of hardware here to show you. Well, first of all, the meters in Japan, they look very different, and actually they look different in different regions of the country even. So this is a TEPCO style meter, Tokyo area style meter. So it's digital, it has modules you can and power going in here. Now, this is built by TTMS, Toko Toshiba Metering System. It is a joint venture between Toko Electric and Toshiba. If you'd recall, Toshiba actually bought Landis & Gyr a year ago, I think. And so for Toshiba, Landis & Gyr is international market. In the domestic market, it's TTMS here. TTMS also provides data collection. Now, this is an example of a data collection unit where it's a CT. You have these devices called CT clamps, current transformers, and they basically clamp around wires, and it detects the current that's running through. This is a 6-channel current transformer detector logging system, which has like a little SD card that can log in, or with the network, it can transmit the real-time data. And now this is the main subject of the talk today. I need to watch the time. Make sure that I know what time it is. So this is called the STiNC, Standard Toko Intelligent Network Controller. This is the second version of it. You see, this is the first version here. Okay. Starting the first version, it is running Java. This does run Java SE embedded on a Linux platform. It is running an ARM Cortex-A, and I'll go over the specifications later on. This is what we are talking about in terms of the common platform. So this type of device allows real-time data to be collected and also control signals to be issued to various other networks or directly to devices. And so if we go back to that concept of the T-step, there are many facilities, different kinds of use cases, but a common platform can be used to basically serve the demand-side management of all those areas. That's the concept. And so there's a strong need to have a very generic yet powerful computing environment and platform to be deployed at a low cost. Okay, so this is called the STiNC. Sometimes we just call it the ink. It means the same thing. Okay. Other products in Toko's lineup, well, big stuff like the switches that basically route energy itself, transformers. They also have, Toko also has meter maintenance programs. Unique to Japan, in the United States, for example, when a meter is deployed, well, it's deployed and doesn't get replaced until it's broken, right? In Japan, there is a law that states that every 10 years, the meters need to be retrieved for calibration and replaced. And so there's opportunity to actually renew some of these meters every 10 years. So it's a very different kind of a market. And so right now, this whole sea of change is happening because of the triple disaster. Japan is changing its current meters, which are smart meters, but they're mostly AMI smart meters that have networks that are facing outward. And it's going forwards towards having a meter that has network capability facing into the building and premise for demand-side management. Okay. And then my company, Wireless Glue, we do software. We don't do hardware. Well, we do a little bit of hardware, but we do software. These are two products that we have. Let me just start off with the easier one, which is the bottom one. How many of you have heard of Zigbee? Okay, well, Zigbee, right? So we've been heavily embedded into the Zigbee world. We interoperate with a variety of smart meters existing in the United States and elsewhere. Meters like Itron, Silver Spring-based meters, Landis Gear, Elster, whatever. They all have Zigbee chips in them. There's California alone has about 12 million Zigbee-based meters already. And if you've been following the news and what the Public Utilities Commission have been doing, basically they're going to be turning on these Zigbee meters starting this year. There's a pilot program that's running. Each of the investor-owned utilities will be turning on about 5,000 of these smart meters. So if you know someone at the utilities, you should ring him up and try to get on that program so you can get to turn on your smart meter and attach devices to it. I've already put my name in the list. So we provide, the first thing we provide is a in-home display. The in-home display communicates directly with the smart meter. It provides full security, 128 AES encryption through elliptical curve cryptography, digital certificates. And so we work on the firmware on that device, and it's a little refrigerator magnet. It's about this big, and you flip it on, you turn it on, it connects to your smart meter, and you can have a histogram of your energy and so forth. It reads the meter every minute in this case. The meters have a 30-minute kind of summation functionality. Now, the other product is a pure software product. This is our flagship product. It is a middleware that is abstraction engine for different communications that are used in a variety of use cases. So if you recall the picture of T-step, there are many different types of facilities, different types of networks in the facilities. What you want to do is to draw information and provide control to all those different kind of networks. And in order to do that, well, one way to do that is you can basically make solutions based on each of the individual networks and protocol commands, or you can make one solution, one application to handle all networks if you had an abstraction layer that allows you to actually send those signals out automatically to different protocols and networks. And that's exactly what we do. Okay. And we connect that through web service to a cloud server, and we can receive demand response dispatch signals from standards like OpenADR, which is Open Demand Response. And we call that the smart edge. So let me talk a little more, or a lot more, about the STiNC itself, the standard Toko Intelligent Network Controller. It provides solutions for commercial businesses. It's ready-to-use energy management software, Eco.WebIV, built in. And we'll be talking a lot more about the Eco.Web. I think it's quite unique in the industry how this is done, and I think we want to highlight how what kind of functionality it provides. It's based on Oracle's SE Embedded platform. It's highly expandable. Clearly, you can see the different attachments here. It's an industrial design, and so it has inputs, outputs, and it's meant to be put into breaker boxes, that type of a setting, and to connect different kinds of sensors and different measurement equipment on it. And as I mentioned, in the overall T-step, it provides for support for a variety of business models. It can be used for aggregators, it can be used for utilities, it can be used in the context of building energy management system, anything pretty much you can think of that you can create a business application on. Okay, so a little bit of specifications. It is based on Java SE Embedded. Some of the input-output, one thing is it uses one wire. How many of you know one wire? Not much. Okay, well, it's one wire. And what it is, it's one of the simplest form of network. It can be, you basically connect the device on, it recognizes it automatically. It is quote unquote plug and play in the functional sense. It's not in the official term plug and play used by Microsoft and stuff, but you just plug it in and it recognizes it works. There are a variety of sensors. Toko provides a variety of sensors to be installed in the buildings. Humidity, temperature, whatever you can think of. There are different kinds of sensors for it. All you need to do is plug it in. It's automatically recognized. Once you turn it on, it enumerates these devices. It figures out, it lists it, and it starts to draw data out of it automatically. Okay. It has isolated digital input-output. 4 input, 4 output, high-speed USB, LAN, RS-485. The RS-485 is used to communicate with other supporting devices. Example is this data collector. The data collector can be connected directly as RS-485 or through Ethernet onto these things. It has an operational temperature range which is geared towards industrial commercial settings, -20 to 60 degrees Celsius. That's pretty cold and pretty hot, with very high relative humidity. It is running ARM Cortex-A8 from Texas Instruments, and those are the dimensions. So just a word about how the software is arranged. There is Linux. It's running on Linux, and on Linux there is JVM from Oracle. And then there are various communication drivers for remote maintenance. And these are options for use in various business models that I mentioned. Some of the business model is, for example, if you take one of these, you can provide a service to a customer where, okay, here it is, you can go install it, plug it in, or you can have a technician install it, and you'd want to actually update the software at some point, right? And so one way to update the software is you can have an OSGI framework, and then you have automatic deployment, or you can have other third-party remote maintenance systems installed. So this platform provides for canned, I guess, not the canvas can, but canned as in embedded here. Some remote software deployment capabilities. In Japan, Toko uses IIJ's system. That is IIJ is an internet ISP provider, and they provide a commercial service to remotely access and deploy software. So that type of remote deployment software is installed here. As a web server, and the application Eco.WebIV comes installed by default as a standard application. And then there are various sensor communication drivers. So that's the complete package. It's already in here. You turn it on, then the Eco.WebIV application starts to basically operate. So here's a little picture of how things would normally be attached. Various sensors, electric-related sensors from meters, where usually when you have electric meters, these are pulsed signal, and it'll pick up the pulses and measure the signal. Japanese meters have different, U.S. meters have ANSI C12 tables and stuff, but Japanese meters have different standards. So this is geared towards Japanese meters here. If it's not the Japanese meter, then you would we provide a Zigbee solution on it. There would need to be a radio attachment, but there's a Zigbee solution, and the Zigbee solution will then allow you to read the ANSI 12 through the Zigbee Smart Energy profile. So it can work both in Japan and the U.S. Power measurement, like one of those from TTMS. That can be connected to expand its capability to do sub-metering. So if this is connected near a mains panel, then you can actually add more CT clamps for sub-metering, which sum up to what the actual meter reads. Other sensors are available: water flow, temperature, humidity, some other just generic analog input and digital input output. Now, as I mentioned, there is the unique capability of this unit as a standard feature is it's able to do this plug and play. So you actually plug it in, it knows it's a water sensor. You plug it in, it knows it's a temperature, humidity sensor, automatically configures that information and displays it through the Eco.WebIV. And the Eco.WebIV also has basically a RESTful interface so that you can draw that information out too, in addition to having its own web-based user interface. There are high performance mini circuit recorders that I mentioned that's connected directly to it. You can use USB memory. Other standard systems. So imagine this to be in a factory, and you have process engineering, process management, and you have energy thresholds that you want to set along a manufacturing process. Maybe it's a thermal process, maybe it's a very electric, intensive load type of process, and you want to have alarms, right? So this has threshold setting capability and also mail servers. Essentially, it has a mail server in it, so that it will send an email out to you to alert you that you've been over your limit, or you're about to go over your limit. It also has the automatic. It has a auto configuring. Let's put it that way. Auto configuring driver that you can connect a network alarm. This little kind of alarm thing. It's also plug and play. You just stick it on, and it'll respond to the threshold, and it'll start to actually show the alarm. So it's very, very easy to use for process-oriented management too. And in fact, that's what it's been designed to do, and it's being used that way a lot in Japan. File transfer is used to bring data in and out, for example. That's not the only way. You can use HTTP too. And it will be reading its time through a network, a time server. Yeah. So just a little bit background information and why and one of the advantages of Java, I guess, is this point here. You see here that the Eco.Web itself started as an application in 2004, and 2006, 2010, and 2012. It's gone through several iterations, all written in Java, and a lot of reuse of code. It's been the first time it was created took a lot of man hours to create, but it's become basically less and less, and the marginal benefit has been increasing. So the idea is that the cost of development, at first, you kind of plunk down a lot of money to start the development. And then 2006, well, a little bit less of money that you plunk down, but you get more marginal benefit out of it. And so it's additive. The effect is additive. And the big benefit of it is the fact that, or why we can derive that benefit is obviously because it's all written in Java. There's a lot of reuse components and so forth. 2004, 2006, 2007, and then now 2012 version. Very little upfront investment to create the 2012 version with high return is the idea. And so that allows both the software side cost, the software costs were low enough so that the total solution can basically, the price of the total solution can actually go down. And especially if you consider the increase in processor power, you're getting better hardware platform, more processing power, more software capability, less and less price. So it's a good cycle. So instead of doing a live demo, this is just giving you kind of an overview of what the Eco.Web 4 does. Here, this is the main screen of Eco.Web 4. The Eco.Web, this here, that's in Japanese. It says Echo on it. It doesn't look like it says Echo on it, but it is Echo. Okay, but it's a logo, so it doesn't have to be translated into English. Okay, this is right out the bat. You turn it on. It has, it automatically configures and starts up. It detects whatever's plugged into it, and then figures out all these sensors that are available on the system. And there are values, thresholds that are set to it, and it'll start to basically, data log all this information, and it'll be creating files, updating the file with timely data, and then produce also a summary report. So that's all canned in this basically Java-based software running on SC here. And this is an example of multiple types of sensors that have been actually connected to it. So this is one group of sensors. That's another group of sensors. There's an overlay of what percentage of the threshold it has reached with the bars here. You see that on the values field, there's a number and then there's some color to it. And the color kind of goes all, it's a bar graph essentially. And it shows you how much of this threshold or how close to the threshold it is. On this side, you have the menu of various settings and data access that you can have. So this is demand monitoring. Obviously, this unit is geared towards demand side management, and so the whole idea is to provide that data. Visualization is one of the most effective tools of demand side management. Allows the energy managers to basically see exactly what's going on and enable control. Now, one of the key features of this version of the Eco.Web and the STiNC 2 is that it's better in real time. It has better software capabilities, so now it can carry a lot of more powerful software on top and allow for control. So this graph right now just shows you visualization, not control, but by setting threshold, it can actually initiate control. Some of the interesting things it can do is, you see these bars here. that is, you don't set just one control. You can have time-dependent thresholds. So that's why you see these step functions. So you can set different threshold levels. It's keeping track of how far it's getting to that threshold, this line here, and whether it's in or out of the predicted amount, baseline amount. And it'll then, if it hits that amount or if it goes over it, then it's configured to basically send alerts through its simple mail transfer protocol. And so it'll send out a mail to you if you so configure it. Or because it has a REST interface, you can cause other things to happen, including direct load control, for example. This is just another way, one other way to display the information. It's your typical bar graph with the different portions represented in the bar graph. So it kind of gives you some high user interface visualization capability for reporting. And all this data is provided for retrieval through HTTP and FTP. This is another screen that's provided again, which is setting of threshold levels. Now you'll notice, like in the middle, well, just this part, there's a contract. So most of the electric contracts have demand contracts. So you're not supposed to go over a certain amount of demand. The reason for that is that the actual power line that's actually connected to your factory or whatever, it has a capacity. And you don't want to go over that capacity because things will start to burn or melt or something. Right. And also having demand contract implies that there's planning, supply side planning going on the utility side, and you better not go over that planned amount because that's what the utilities have have planned in their purchasing of energy. Right. So there's a contract level. And you never want to go over your contract level, and so you have levels in which you want to actually initiate action, right? And so you're able to create either a flat action, or you can have like basically timed action and a time segmented action. Okay, and so the first level may be notification, the second level may be an alarm, for example. Okay, and then you'll see here an alarm lamp setting. If you remember, there's that alarm light. Those are a network alarm. It has an IP address to it, and so when an alarm gets hit, basically it'll send a signal and it'll cause the little rotary light to go on. And you'll notice there are level 1 and level 2, so you can have different colors actually turn on. So these are all plug and play. So very, very easy to use. You can turn alarms off. You can also specify record of the biggest demand through this drop-down menu. Now, this is a different kind of a configuration setting, sensor setting. Recall that I talked about a plug and play. These are different one-wire sensors. Each one-wire sensor has unique ID. You can basically plug it in, select it, assign the value if it's a new one, and give it its characteristics so that when you actually do re-plug it in, it'll recognize it automatically, assign a unique ID to it, and then it can start pulling data out. And then you can group different sensors into one profile group. So you can select to show a screen where it only picks out a certain number of sensors, and those sensors can be referring to a group that is for one floor or one section, one manufacturing process. So it's a nice feature to have here. So benefits of why it was done, why use Java, I guess. Especially with the more powerful processors, improved platforms, you have very good performance, stable operations. Now, as previously mentioned, there's very high percentage of reuse of software assets, so that as if you have incremental development, from a big organization standpoint, I mean, you don't do a scrap and build in these things. Basically, you can have a development team that can continue to incrementally increase the value of your assets as an organization, and with very little continuing up development fee. So therefore, you have also faster time to market because you can build on top of what you've already built. And of course, because it is Java, there is a very rich development ecosystem, so that developers also can build more sophisticated applications in very short time. So now let me describe the next step or the next evolution. I like to just kind of point out, this is one, perhaps I would say maybe the first example of this platform being used as a base on which to build new smart grid applications. And so now I kind of shift to what I actually do with our development team locally here. And so what we provide is that we build on top of that Java platform, embedded platform, to provide a energy management and control system. And so this is kind of an overview of it, where we provide software on this on-premise gateway that retrieves real-time information and also provides control, and then forwards that information to a cloud platform to actually then allow you to do remote data viewing and control also, and also to serve as an interface to other cloud-based applications and aggregation of these units. So if you apply it to a commercial management company, some of the key systems and turnkey solutions you can build is that you can have a aggregation of building energy usage and tenant energy usage, and easy to expand offering. You can provide over-the-air upgrades, so forth, through this isn't a case. It's for example, if you have Zigbee expansion, we can actually update firmware through Zigbee, or we can actually update through the Wi-Fi, whatever. Building owners, if you actually apply this solution, avoid penalties that's related to energy consumption and so forth and so on. And tenants, this is basically a tenant-based building, provides compliance with government mandates on reduction in energy, reduce energy overall costs, and so forth. This particular solution, this formal solution, is being planned and applied in Japan because of the big energy problem there, and that's the main partnership that Wireless Glue and Toko has. Let's look a little more about up and coming use of this type of a platform, why we call it a smart grid controller. So you can imagine having this type of a gateway in various different buildings. I think one of the patterns that has evolved up to recently is to have a very simple gateway at each of the locations. Because, well, it's simple because it was low cost, but simple because you couldn't have a non-simple solution. It's a weird way to say it, but the costs of, for example, Java SE-based platform would have been too high to install in every location and still be profitable. It would have meant like you wanted to put a PC in every location. But now you don't actually have to put a PC to have Java SE. You can just basically put these ARM Cortex-based units, and that's low cost. We're talking hundreds of dollars, right? Not thousands of dollars anymore. And you can have the same level of functionality, and you can have the same level of sophisticated application deployed at each of the location. The level of sophistication meaning that you have multi-protocol interoperability across different networks, so that if a dispatch signal from a demand response system comes in this case we're talking about OpenADR through a cloud service, well, all the data, all the dispatch signal control can then be distributed to each of the individual units. Each of the individual units would actually have very different kind of networks involved. Some of them may be Zigbee based, some of them may be BACnet based, long work, or even one location may have a whole mixture of those things. And so when a DR signal comes in, a sophisticated gateway can basically process that signal and then essentially through a abstraction layer send out the appropriate signal out to the native protocol that's existing in that building. That can be done because you can actually install a sophisticated software. You can do that because the cost of software development and the cost of platform has been driven down, and you can run like an SE platform in these gateway devices. So that's what we provide. Solution benefits. It's good for this is very effective for commercial property management companies, building owners, tenants, or even energy aggregators. One of the biggest roadblocks to demand-side management has been that you can do demand-side management of very large facilities, and you can, but it's very difficult to do demand-side management of the biggest population of energy users, which are mid-sized companies, because they have a whole mismatch of devices. It's not standardized. It's everywhere. It has to be low cost. But finally, you can address that, basically a sweet spot of the market with a low-cost system that can do multi-protocol. And it's probably the first time there's a convergence of technology that allows you to address that particular market space. And that is the space that has to be addressed in order to have effective demand-side management. And so benefit is that you can have one platform with very flexible technologically flexible platform to apply to all different kinds of situations. And we're looking at Toko. Toko has, like, for example, 2,000 plus customers which have inks that we can now replace with new platforms and then provide effective demand-side management and DR there. That was wireless glue, and I want to take a little bit of time now to explain this type of device, which is from Toko Toshiba Metering Systems. Just recall that it comes in a combination. So you'd have a smart meter which is connected, which the STiNC connects to, and now you want a sub-meter. So this smart meter only gives you one value, right, for the entire circuit that you're connected to, or circuits that you're connected to. But in fact, for effective energy management, you want to actually granularize that. I don't know if that's a word, but you can get more. You want to get more granular to look at individual circuits and collect that information. So this is the type of device that allows you to do that. This way, because you can connect different types of CT meters on it, and it's very accurate too. The idea is that, well, okay, you want to do energy management, and you want to plan the improvement. You create a plan, and then you apply it, and the plan, you check it, and you act on it. So this device allows you to, when you're in the cycle of energy management, of PDCA cycle, to actually apply this type of a device to actually check on your energy management plans. And different kinds of ways to look at it. You can look at one single item over a span of time, or you can look at many items over the same, over a single day. So just to give you a little kind of explanation of what this device does is that, as I said, it'll connect up to different circuits with the CT clamp, and then it'll collect all the data. It can store it, or it can actually forward it with a connection of RS-485 connected. It's a serial connection to the STiNC, and the STiNC can then forward that information, log it, or you can add different applications on top of it, and then you can do more analysis on it. So various different ways, it can store that information in an SD card and a CSV. It can put that information out even over LAN. It will keep 175 days worth of measurement at 30-minute intervals, and as I said, 6 circuits is the maximum that it'll handle. That's used in combination. There are other SCADA type devices that TTMS provides. Just to go and finalize on this discussion here, I want to give a little bit of the planned roadmap for the STiNC. 2012 right now, this common platform, 600 megahertz Cortex-A8 SE embedded, to be used in building energy management, factory energy management, and automated meter reading. It provides various support for sensors. Next year and going forward, development plans are to miniature, make it smaller, right? So you notice that it's the same processing power, but it'll shrink in size. Additional security through Java card, like SIM card type concept, and additional capability with automated demand control, demand response. Dispatch signals like OpenADR, it can be, it'll start to handle OpenADR, and with the appropriate software, it'll determine based on the current price, time of use, or real-time pricing, what to do in terms of control, or the DR may actually prescribe a load amount to back off, and then it'll send a direct load control signal. It will include, for example, in Japan, the standard has become EcoNet. EcoNet, not Eco.Web, EcoNet. EcoNet is a standardized object model in Japan for various load devices, and those would then be included into this platform so that it can actually be compatible with all the different kinds of automated smart devices, let's put it that way, smart devices that will exist in the Japanese building environment. So I think one of the takeaways that you should have is that smart objects in Japan will use a smart object model, which is EcoNet. And there will be a variety of physical layers and networks to which to communicate with that smart object. But the object model itself is unified. And so demand response will act on those object models to actually control them. That's the whole kind of paradigm that Japan has adopted starting next year. SCP 2.0 can be Smart Energy Profile 2.0, which is an American standard, is being looked at in Japan. Toko will be adopting SCP 2.0 for American market, but for Japan market, to follow Japan market, it requires EcoNet, but the physical layer and the network model is not actually set for EcoNet, and therefore SEP 2.0 is also one candidate to be used for transmission of the datagrams to the objects. Additionally, their collaboration with cloud services. Demand response signals are essentially cloud services already. And so while these devices are sort of atomic in the sense that it's there, it's hard, it exists in the premise, that information, that control will actually then be pushed up into a thin cloud layer, and then a connection enabled to cloud services to actually send signals to it. We have some prototype pilots going on right now with American demand response dispatch cloud services that we can basically use OpenADR to send telemetry data, receive OpenADR signals, and then in effect direct load control on equipment through the STiNC. So we already have that set up. 2014, yet smaller device, yet cheaper device, yet more powerful, greater than 1 gigahertz processor speed, SE embedded, high security with Java card. Pretty much, application and use cases is building energy management, factory energy management, home energy management, automated meter reading, demand response, and more features is the plan. To wrap up, Toko would just like to convey that there are a bunch of, there are maybe 4 different patterns that Toko likes to engage with other companies. First is offer existing turnkey application solutions to them, or together build cloud services and develop specialized energy management, or combine with third-party software and services, or just simply partner with someone for sales of sensors and other solutions. So they're always looking for distributors. And that's it. Any questions?
Yeah. I'm curious what the memory footprint is of your ink, and how much of that is consumed by the SE Java and your application.
Okay. It's 256 megabyte on it, and the flash, yeah, and the everything on it only consumes about, let me think, our application consumes about 10 megs, and so you actually have ample room to operate. Sorry, 512 flash, 256 megabyte RAM. Yeah. Alec? Yeah. Mm-hmm. Yeah. Yes, that's part of the. Let me just explain to him first. パートナー企業さんと、協力する上で、ソフトウェアを搭載した場合に、そのソフトウェアのインターフェースを開示して、そのインターフェース経由で、協力するかどうか。And yes, we do that, and in fact, we already have a model that's in play right now to do that with a demand response demand response provider. When we talk about demand response, there are 2 types of providers. One, well, there are several types of providers, not just 2, right? But an example is an aggregator, and they have channel to the customer channels. They aggregate the customers, and that they have their own technology. Or you have demand response platform providers who are basically the server side. Companies that provide just the DR signals, and that would be like a third-party cloud application. We call them smart grid application providers. And we actually have a partnership going right now where one way is a common interface. If you look at OpenADR, there's OpenADR 1. Who knows? Who's heard of OpenADR? Just a few. So I'll just explain a little bit. OpenADR is a short for Open Automated Demand Response. It used to be called AutoDR. It started in California, in Lawrence Berkeley Lab under Department of Energy after the energy crisis, and it evolved after the whole smart grid initiative. It evolved into a national standard called OpenADR. The national standard, I mean by National Institute of Standards and Technology, NIST, has specified a technology milestone for interoperability for the smart grid, and it is one of the key official standard technologies to be used in the smart grid, so that one technology, one type of well-defined object model and interface is provided for the entire smart grid, so all the utilities use the same thing. OpenADR is one such standard. It is the specific standard called out by the United States to implement demand response systems. It is implementing a common information model based on ISO TC Guide 57 and already used, it's the common information model already used in the utility space. And OpenADR defines how a utility or an aggregator, energy aggregator, sends signals out to the load consumption point to affect load control or basically demand management. Right. So one of these cloud service providers is a DR signal technology provider. They would actually sell their software to, or sell its software as a service to a aggregator who has the channel to market, and they would then, it could be a utility. Utility would buy that service, and then monthly they would pay for it, or per signal they would pay for it, and they would send a DR signal out to their customer base. But the signal has to actually be received somewhere, right? And these are type of devices that it would receive, and then through these devices, an actual physical demand management happens. So we actually have that. OpenADR provides for a standardized interface for that signal. It has created a data model to allow for that, but it's not everything. It doesn't do everything. So we do. We work with our partners, discuss the API, and then basically send special telemetry up so that they can do their load curve prediction, so forth. And so we do that actively, yes. I think we're up. Time's up. Any other questions? So if not, I think you can just give us your cards and stuff and carry on the conversation. Thank you very much.